Okay, so hi everyone, so welcome to the third and final part of the tutorial about how to train faster RCN network to detect door openings from bitmap floor plans. So last time we trained the basic faster RCN network using two different approaches, one without data augmentation and one with data augmentation. However, the end results was not that good. The F1 score was around 0.4 and the recall was somewhere below 0.3, so I would hope that we would at least get to somewhere around 0.6 for both recall and precision and F1 score. So this time what we still try to do is that we still try to improve the model using this called feature pyramid approach. So the basic faster RCN, we are only using the last layer from the backbone ResNet network, and for door detection it's possible that the resolution just get too low. However, in this feature pyramid approach, instead of using just a single last layer, we are using the feature maps from all the 4 layers, and then we generate anchors for each of those layers. Essentially, otherwise the network and training goes exactly the same way. So in this time, so let's not go too deep. Let's simply just look how does the backbone result looks, and then let's go back to the collab. Okay, so if we quickly look the feature map tensor, so we can actually see that this time it is actually a dictionary with 4 keys, so each of those keys corresponds to the layer in the ResNet, and then each of those, the value is then the feature map. So we can see that in this case we simply have the feature maps for all the features, for all the layers. But I guess that's enough for the network, so let's go to the collab and let's see how do we perform this time. Okay, so now we're again back in the collab side, so we're ready to run the training. So I have already copied the required files to drive, and from drive back to the collab, so it's simply enough to just start the training. However, let's increase the number of epochs to 300 in this case, and let's see if everything goes smoothly. Takes some time, but no errors yet. Okay, it seems to be running okay. Let's see, we get the benchmarks. Okay, so it's running okay. So then again, let's wait some time and let's see the result. Okay, so we finally get to the end of the training, and let's quickly look how the basic metrics look. So as we can see, so this time the metrics looks much better. So the recall is around 0.8 and the precision around 0.5, meaning that we made about 1 wrong guess per every correct guess. I think the precision could have been a bit better. The F1 score is around 0.6, which I think is a pretty good one. You can also notice that I added this 0.75 threshold here. Maybe the nice thing to see here is that it doesn't improve the precision that much, but the recall significantly drops, so it means that the 0.5 threshold, which kind of sounds natural, seems to be performing the best. But let's not just rely on the metrics, so let's copy again the output results from the last epoch. So I have again saved the output from the region proposal network and also from the final detection. So let's see how they look, if they actually look any better, and then let's again finally look the TensorBot to see how the training actually behaves. Okay, so let's look how the detections actually look. So after every 15 epoch I've stored the region proposal network output and also the final detections from during inference. So let's see what's happening there. Okay, so this looks pretty good. We can see that all the doors are detected, not that many misdetections. Also in this case, even it's not that well resolution image, we can see that all the doors are detected, not that many false positives. Same here, looks pretty good. Okay, here we can see there's some issues, so this is definitely a window as well. So we can see that the doors are detected very well, but we get some misdetections from windows, so there's something to improve. We can see the same here. So seems that this kind of floor plan image is a bit problematic, but otherwise it seems to be pretty decent. Again, some windows there, so it's good but not perfect, especially the windows. For example, here all our windows here, and we are getting those. But yeah, in general good, but lot of misdetections from windows. Let's quickly look how the region proposal network output looks like. So start here. Okay, yeah, okay. Well, we can see that there's a huge number of proposed regions. So this is crazy. Okay, so I guess there's a bit like a problem why we get these windows. So the problem here is that why we're getting so many detections is that in the when we decode the proposal, so I think the score thresholds, whether we accept the proposal or not, was just like 0.05. So the idea is that we get a lot of regions in the final ROI phase, but obviously there's too many of them, so we should have increased it to something like 0.4 at least. It would at least definitely make the trading faster and maybe got some of those wrong detections. And then another problem is that why do we get those windows is that in the second network, in the ROI network, we select the training samples, select the negative training samples in such a way that it's something like there's like a minimum intersection of union defined, so we're not accepting negative samples if the EO score is below, not above some small threshold. But of course for windows, the windows are never overlapping with the actual bounding boxes, so for that reason we're not getting any negative samples from windows, so that's a problem. So that's something that we could improve. But yeah, as to summarize, so in general the outcome was, I think it was pretty decent based on the actual detections, some misdetections from windows, and also way too many regions proposed from the region proposal network. So there's something to do, but I'm relatively happy about that. Let's quickly still look at the TensorBot if there's anything interesting. So here's the test average loss. I think it looks pretty good, so we can see that it's rather smoothly get lower and then it plateaus here. So we can maybe deduce that though extra training step would not have help. If you look at the recall curve, we can see the similar behavior. It increases steadily and gets then plateau. We can see that the 0.5 thresholds performs better than the 0.5, and the same is also for the precision, so it seems that this natural 0.5 threshold would be the best one. But yeah, I guess that's it. So yeah, I think I'm pretty happy about the detection quality, so we can definitely detect the doors. We get some misdetections from the windows. There's some obvious things we could still do, but let's not go there, at least in this tutorial. But anyway, I hope you get some helpful information about this. So thanks you and see you next time.